All right, so next up, I want you guys to just see a quick tip for something like floor plates, where you're kind of doing multiple iterations, and it's a kind of smart way of doing it. What I typically do with floor plates is I take whatever kind of base I have, depending on how complex that base is. If it's like a super odd shape, I might just have to do a square. But usually what I wind up doing is I take that base surface and I multiply it, I scale it up by 2, and then I just kind of stack it, and then I subtract it out from the overall boundary of whatever the profile is that I need for my floor plate, right? So, so essentially what that means is this surface right here is what I'm going to be operating with. So I'll just go to transform, affine, and scale, and I'm going to scale this surface from its center point. So make sure you grab the area function. You're going to scale it from its center point, and I'm going to put a scale factor of slider from just 1 to 3. 1 to 3. 2 will be fine. I don't see, particularly in this exercise, scaling it up by 2 definitely is going to be fine because we have a straight up profile. But if you have sort of like a warpy winding tower, you might not be able to do that. Okay, so then after that, we have to go through the process of actually moving in order to copy the scaled surface upwards. So it's really just going to be a move command, and I'm going to move it with a list of distances. So I'll go to transform Euclidean. I'm going to use move.
Sorry, what is area connected to?
Same thing, surface.
Give me an error.
Might not be a surface. Hang on. All right, moving on. So I'm going to move this. So the geometry I'm moving is this right here. And you can see that it's already kind of doing what we want it to do. But I just want to do it in a little bit more of a controlled fashion. We have to move it along a particular translation vector. In this case, it's going to be unit z. So I'll just do vector unit z. And with unit z, I'm going to create a series of numbers, and I'm not going to do a range of numbers this time because, well, it depends on how you set it up. But I'm just going to do a series of numbers. Yeah, actually, yeah, I'll just do a series. So I'm going to go to set sequence series. And I'm going to create, the first number in the series is going to be 0, because I want to make sure that I still have a floor plate. Well, actually no, my floor plate on the bottom floor is going to be a little different than the rest of them. So I'm just going to start my first number at 10. And that's going to, well, I'll make it higher actually, I'll make it 12. And then the step size is how far every step is going to go. So the step size for me is also going to be 12 because I want every floor plate to be a little bit higher. Actually, I changed my mind. I don't want it to be 12. I want n to be 12, but I want the first one to be 15. Because usually in like a building, your first floor is a little taller than others. I just want you to see that it can be different. And then after that, it's just the count. So the count is what's going to be a variable. So I'm going to say 0 to 25 on this one, and I know I'm only going to need like 5 or 6. No, actually, I'll need like 8 or 9. So when I plug the series in, make sure you've got something like 8 different ones, and you plug it in, and it creates floor plates for the entire building. What's that? Well, yeah, so you're going to have to calibrate your slider. So if when you plugged it in it had too many, you can calibrate your slider down. You don't have to. The good thing about having too many is that wherever it tries to do a trimming function, you'll see that in just a moment, it'll just not count it when it doesn't trim, and so it'll just delete that from the calculation. So this is a case where having too many is okay.
Did your top panel finish flush on your building?
Nope, and it's okay if it doesn't. It doesn't have to. I'm not worried about that level of detail right now. You will be when you design. Okay, so with this, to create the floor plate, we have to do a couple of things. We have to create a surface that gets trimmed out by the volume that we generated. This one right here, right? Because this is going to establish the profile of our floor plate. And then we're going to create a surface and extrude it in order to give it some thickness. So let's see. Yeah, so what I'm going to do here is go up to intersect. And there are a bunch of different ways that you can do intersect functions. But one of the easiest ways here is this one right here. It's called brep. And what that does is it says that it solves intersection events, which is a little confusing for the first-time user. Essentially what that means is it's going to draw a curve wherever two breps intersect. So I might have to convert the surfaces to breps. But anyway, if you take this in here as your A input and you take these in here as your B input and you look at what it's doing, in fact you can turn them off in order to understand what it's doing, you'll see that it created curves wherever they would intersect that particular volume. I don't know about you, but I think that's a really nifty tool. So then moving forward just a bit here, once you have a closed profile curve, and it's important that you know that these be closed. If it's not a closed profile curve, then it won't work. You will be able to just take a param, take your surface, and you should just be able to plug it in and get a surface. Again, a very nifty tool. All right, now, with this, you have the ability to just create your floor plate, and your floor plate is obviously going to be another extrusion function. So I'll go to Surface, Freeform, and Extrude, and it's going to be on the unit Z. And so I just need to define how far it's extruding, and so I'm just going to put a slider 0 to 1.00. Many slabs are for a building like this are going to be something like 6 inches, maybe 8 inches max if you really have a heavy load. So just something like a half a foot will be enough. Pretty cool, right? I think so. Okay. Any questions? Okay. Huh? No? All right. I'm going to stop this and then move on to developing some substructure for this thing.